Hello students, now in class 12th, today I will tell you about the biasing of junction diode. Biasing of junction diode. The method of connecting the junction diode in an electrical circuit is called biasing. The method of connecting the junction diode in an electrical circuit is called biasing. So we know that in junction diode we are having the two parts, P and N. So its biasing may be of two kinds. When P is at a higher potential, then the N part, then it is called the forward biasing. If P is at lower potential, then the N part, then it is called the reverse or backward biasing. Biasing is of two kinds. Number one, forward biasing. When P part of junction diode is at higher potential, then that of P N part it is called forward biasing. Forward biasing. For example, suppose you are having this this is P and this is now N, and this we have at positive voltage and this we have at negative voltage. Positive and this is at negative. Then this will be called the forward biasing. Or we can have the symbol of this one is also like this. This is positive and this is negative. Here the circle, this triangle represents the P part and the vertical line represents the N part. So this is the symbol of diode, junction diode. Symbol of diode. Now this is also this is now P part and this is N part. The triangle represents P part and this vertical line represents the N part. This is also the. So when this P part is at higher potential than the N part, then this is called the forward biasing. Second is backward or reverse biasing. When P part of junction diode is at lower potential then that of N part, it is called backward biasing. Backward biasing. So what happens here that this, suppose we are having this crystal, this is P and this is N, and this is suppose at negative potential and this is at positive potential, or we can have that this, then this is at negative potential, this is at positive potential. Then both this, when this kind happens, then we are having the backward biasing and the or the reverse biasing. So this, you can say that these two are just opposite of each other. Here P is at higher potential, then that of N, and here P is at lower potential, then that of N. So when this happens, then we have having the backward biasing, and this happening, then it is called the forward biasing. Now I will take that what happens when the when this junction diode is connected in forward biasing and the reverse biasing. So I will take the forward biasing of the conductor of this junction diode. Forward biasing. Now here we are having this we are having this the depletion layer. This is your P, this is N. So now in P we are having the holes, and now in N we are having the electrons. and this is a depletion layer. This so much, this is depletion layer. And here we are having the negative, here the positive. This is due to the fact that here in P part we are the impurities are the accepted impurities, so they are negative ions, and here the impurities are donor type, so they are positive ions, and here is the electric field. This is the electric field, EI, and now this is connected in this way. This is the cell, and you can have that the current will be there, and the applied electric field is in this way. This is the applied electric field, E. And you can see that this applied electric field is just opposite to the internal electric field in the depletion layer. In forward biasing, the applied electric field E is in opposite direction of internal electric field EI in depletion layer. In depletion layer. So because this is opposite to this one, and because of this factor, the thickness of this depletion layer decreases. It decreases. The thickness of depletion layer. Depletion layer. So resistance of the diode also decreases. Also decreases. In this situation, this junction diode behaves like a conductor. The junction diode behaves like a conductor in forward biasing. So it easily conducts the current. current the conduction of current takes place. Easy. Now this is behaving just like the electron, and you can see that current flows from P to N. So when this happens, this will move in this direction, in the direction of the applied electric field, and they move opposite to this one. These are the electrons. Because electrons and holes pass through junction. Depletion layer. So what happens that first this thickness of the depletion layer decreases, so the resistance also decreases. Because of that, when the electric field, because of this applied electric field, these electrons and holes easily move across this depletion layer, and they contribute in the conduction of current. So this is what about this forward biasing. And now if we take the reverse biasing, and in this case the current is in milliamperes. The current in a circuit. Is of order of milliamperes. Now I take the backward biasing. Backward biasing. Now what happens in backward biasing, that when we are having this crystal, this is the depletion layer, then this increases like this. So we are having this, this is the positive ions. Here we are having this P and this is now N. So we are having the holes. Here we are having the electrons. These are like this. And in this we are having this, the N. This is now positive and this is negative. So you can see that this N is at a higher potential than the P, and the thickness of this depletion layer This is so much from here. This is depletion layer. This is now okay. The current will be like this. The applied electric field is always in this direction. This is E. And here we have the electric field like this, EI. So when this happens, then the applied electric field supports the internal electric field in the depletion layer. Because of that, the thickness of the depletion layer increases, and also the resistance increases. So in this case, there is no free electron and hole in this depletion layer. So almost the current is zero initially. When the voltage is increased, then after some definite voltage, there is flow of the current in the circuit. So this current that flows in the circuit is just opposite to the current that we have here in this forward bias. In backward biasing, the applied electric field E is in the direction of internal electric field EI in depletion layer. It's because it means the applied electric field supports the internal electric field. It increases. The thickness of depletion layer. The resistance of diode increases. Thus, the junction diode behaves like an insulator in backward biasing. In backward biasing. Since thickness increases, so it means that the electron and hole cannot pass through the depletion layer. The electrons and holes cannot pass through depletion layer. And you can see that in case of backward biasing, the diode is behaving like a bad conductor or like an insulator. Initially the current is approximately 0, but when the potential is reached beyond a certain value, then there is a current. So current is very small, that is due to the minority carriers. In case of in case of the forward biasing, the current is due to the majority carriers. There the flow of electron and hole can take place easily. But in case of the forward biasing, the holes are bound to the negative potential and the electrons are bound to the positive potential. Because of that, they cannot pass. So initially there is no current in the circuit. Initially there is no current in circuit. But when the applied potential difference exceeds certain definite value, a small current may be observed. Due to minority charge carriers. Minority charge carriers are those which are due to the which are produced during the application of the electric field. So this is what that happens in case of the backward biasing. So you can see that in forward biasing the junction diode is behaving like a conductor, and in the forward biasing behaving like a conductor, and in backward biasing it is behaving like a insulator or the bad conductor. So this is the two effects, that when we have to use the diode as a conductor, then it should be connected in the forward biasing. When we have to find that the current should be very small, then it should be connected in the reverse biasing. So the current in circuit is of order of microamperes. Is in microamperes. There it was in milliamperes. Here the resistance is very high. This is of order of 10 raised to the power 6 ohm. So this I have to tell you about the what happens when the junction diode is connected in forward biasing and then it is connected in the reverse biasing. And in the next lecture I will tell you about the characteristic curves of the junction diode. So you all like, share and subscribe this video. Thank you.